Alright, so you've heard of sine, cosine, and tangent. Now get ready for secant, cosecant, and cotangent. Let me tell you what the hell I mean. So, a secant is simply 1 over cos x. Okay? This is called sec x. Alright? And is the secant. Don't get confused with cosecant or cosec x, which is cosec x is equal to 1 over sine. That's right. It's the other way round. Okay? And cotangent or cot, that's just going to be, you guessed it, 1 over tan x. Alright? Fantastic. Now, let's take a look at what the graphs look like. We know what 1 over sine, we know what cos looks like, right? Cos looks something like this, don't it? So, you would expect that sec x is just going to look like a bunch of, I would say a bunch of quadratic lookalikes, whereby it'll look something like this, and this is an asymptote. Alright, these two are asymptotes. Why? Because this is 0, isn't it? And you can't divide by 0. So if this is 90 or pi over 2, it never touches that asymptote because you can't divide by 0. Same with the negative. It's going to look something like that. And on the other side, it's going to look something like this. Okay? Alright. Just like the secant of a triangle, the exact same thing is with the cosecant. Where if sine looks something like this, right? You guessed it, the cosecant is going to look something like this. And of course, we don't touch the asymptotes here. Let me actually just draw the asymptotes so I don't confuse you guys. Yeah? Never touches. Never touches. What about cotangent of x? Well, the cotangent of x, if you remember what the tan of x looks like, which is something like this. Yeah, something like that, I'd say. Well, it's in reverse this time. You see, now this, I'm going to do this in purple. Sorry, let me do this in purple. You see where it's 0? Yeah? That is the point at which we don't touch. And also, it's going to go in reverse this time. Yeah? And it won't touch here, here, or here. And it should look something like this for all 3 of them. Yeah, something like that. And that is the secant, cosecant, and cotangent graphs. Is this video helpful? Well, make sure you subscribe so you never miss a video like it. Now let's learn how to actually use these functions. So show that cotangent 30, secant 30, or cot 30, sec 30, is equal to 2. Well, we know that tan 30 is equal to root 3 over 3, okay? And we know that cos 30 is equal to root 3 over 2. So therefore, cot 30 is equal to 1 over tan 30, which is just going to be 3 over root 3. if you want to rationalize it, you can. Okay? And cos 30 is just going to be 1 over... Sorry. Sec 30 is going to be 1 over cos. Okay? Which is the same as 2 over root 3. Or, if we want to rationalize that denominator, it's going to be 2 root 3 over 3. So now, cot 30 sec 30 is the same as 3 root 3 over 3 times 2 root 3 over 3, which is the same as 6 times 3 over 9, which is 18 over 9, which is 2. Okay? So it's literally the same as what we would do if it was sines and cos. It's just 1 over that. That's all the secant, cosecant, and cotangents are. Is this video not making any sense? Well, join my Discord server and ask me whatever questions down below, and you can get your answers that you are after. Now let's look at something like this, whereby we have to sketch the graph y equals 2 sec theta, 1 plus 2 sec theta, in the interval minus pi to 2 pi. Okay? Well, let's get on with it, shall we? So here we have, actually, I'm going to shift that slightly to the right. So this is my axes, y, x. If it's going to be 2 sec theta, we have to boost it by 2, okay? So we're stretching it, and then we add 1. So our points here will be at 3. And then the graph is exactly the same as it's been. So from here, it's going to look something like, remember this goes to 90, right? So this is going to be like that. Yeah, that's correct. Okay, really cool. And if we go on the other side, it's going to look something like this. No, sorry, hold on. That's more like it. Okay. Again, do not touch the asymptotes. And it'll look something like that. There we go. So this is at 2 pi. This is at pi. This is pi over 2. 3 pi over 2. Minus pi over 2. And minus pi. Okay? Now, because we are increasing it by 1, this point here will be at y equals minus 1. Do you understand? So if this was 2 sec, because we're stretching it, it would be at minus 2, right? However, because we're adding this 1 at the end, we're going to have minus 1. Write down the coordinates at which the gradient is 0. That's just going to be the minimum point. So we have here, this point here, which is minus pi minus 1. We have this point here, which is 0, 3. We have this point here, which is pi minus 1. And we have this point here, which is 2 pi 3. Okay? That's obviously just the minimum point at which the gradient is 0. Now, deduce whether the minimum or maximum points of 1 over 1 plus 2 sec theta, and give the smallest points of theta at which they occur. Okay, so the first thing we need to do is we need to realize is that the minimum value, what's the minimum point of this graph, right? Exactly, it's at minus 1, isn't it? So therefore, right, if the minimum point is minus 1, then 1 plus 2 sec theta is equal to minus 1. And so therefore 1 over 1 plus 2 sec theta is equal to 1 over minus 1, which is equal to, ready, minus 1. All right. So therefore, right, where at which would the minimum point happen at minus 1? At minus 1, right? It would happen at pi and minus pi, yeah? But it's asking for the smallest positive value, so it's going to be at pi. And so therefore for this one, for the minimum, right, theta is equal to pi. So all we're doing is we're literally just using the graph minus 1 to plug it into this, and then we can derive that theta is equal to minus 1 by looking at the graph. Now, for the maximum point, right, we know that, I'm going to do this in a different color. So at max, right, 1 plus 2 sec theta, where's that at? It's at 3, isn't it? So therefore, 1 over 1 plus 2 sec theta is going to be a third, right? And the first place, well, the first positive place where that happens at is, if we look at the graph, it's going to be at 2 pi, okay? So therefore, we can say that theta, in this case, is equal to 2 pi. So it's all about just looking at the graph and seeing how that works. Thank you guys for watching. I hope this video made sense. Do you guys like these videos and you want to pass your exams? Well, you can get tutored by me. Drop me an email and we can organize a meeting and a quote. Keep on learning as you have no idea what you're capable of doing.